Welcome, everybody. We're going to be working on our chapter 4 exercises this evening, but I'm going to do a little like precursor info session basically on an alternate IDE that's included with the Anaconda distribution of Python called the Jupyter Notebook. The Jupyter Notebook is an IDE that is browser based, so it works inside of a web browser, which is kind of a interesting approach compared to like a traditional IDE. It also tends to be, for whatever reason, kind of the preferred choice when you do work with data analytics or artificial intelligence. It just has become that default tool. In order to run this product, you can bring up either your Anaconda uh, navigator, and it's located in the panel. I'm not going to do it that way, by the way. I'm just going to go right to Jupyter Notebook in my start menu and launch it from there. Now, I actually already have it running in the background, and I don't know right now if I'm running a second instance, which probably isn't good for memory, but whatever. Memory is cheap these days, I guess. But I'll have you notice that as we land in the product, this is where we land. You will notice that somewhere in the background, there's also a command prompt window running that basically logs all the activity that's going on within the product, right? And that you just leave in the background. You don't worry about it. I think I actually am running 2 instances right now, not really a big deal. All right. When you launch this product, it puts you into this screen. I don't know if this is where you guys are landing or not, but it shows me my file system. And this is kind of relative to my own personal account inside of Windows. And this is where it places you, which might not be where you want your stuff to go. And I'm just telling you that up front. So, for example, if I pull up a file window here in Windows, if I can get to one, there we go. And I go to my C drive, my users folder, and my folder there. This is the folder that we're looking at, sans all the hidden folders there, but you can see 3D objects, et cetera, et cetera, et cetera. You can see all the um, links. By default, the Jupyter Notebook will put all those files here in the root, and you can see I have a bunch of them. And I want you to notice that when you're saving your Jupyter Notebook work, it does not save your work as a py file, like a py file. It basically is this weird extension, whatever that's supposed to mean. And I think it's like I don't know if I think that first letter is an I, not a J. You think it would be a J, but it's like IPyNB, which stands for notebook. Now, the reason they call it a notebook, by the way, is because it contains more than just the code, right? So typically a py file only holds the code, which is a set of instructions. A notebook, on the other hand, holds the code and the output, and you can introduce what they call markdown language, which is basically annotations to the information. So you can try stuff, run it, see how it went, add notes to it, add instructions to it, etc. It is, despite that fact, a full power IDE. It can do all the stuff that Spider can do, not quite the same way, right? But it can handle all the same types of code. Now, what I'm going to do here is I'm going to go to the new menu inside here, and I'm going to create a new Python 3 file. Right. This is if you want to create one. Now, if you guys don't want to do this, I am going to be working on the exercises here. You keep using Spider or Visual Studio Code or whatever you're using to code your Python. That's absolutely fine. But I'm going to do at least the first exercise or two inside this environment. So I'm going to create a new Python 3 file. Right. The new file will launch inside a separate browser tab. The previous tab is still there, by the way, right? Didn't go away. And now I'm ready to code. All right. So just to give you an example, I can do all the stuff that we can do in Python. So I can do print and say, hello, whatever. Okay, good night, whatever. And then hit the run button, and then it does it. So this is kind of what it looks like. But you notice how this is kind of a different approach, aside from the fact that, the view is different. Spider has a dark theme to it, so it's dark colors with light colored text. This is brighter, so it's dark text on top of a light background. I'm sure that can probably be tweaked. I've never gone to the effort of tweaking inside of here. The other thing that you can do that's kind of interesting is you can also insert like cells inside here, and you can insert, for example, I think I can do a markdown cell. I always forget how to do a markdown cell. Anyhow, a markdown cell is a cell that just contains information, by the way. So I think this is just info here, and it's not executing. The code that executes inside a Jupyter Notebook will be the code in the box that's highlighted. So for example, if I hit run now, nothing happens because there's nothing in the box, right? But if I highlight this box and I hit run, then it will execute that code again. Now, you can't tell that it actually did something because I didn't change, what the output is, but there it is. You can see that it creates basically that output there. All right, so for as weird as this is the kind of primary tool for data analysis and AI work. And let's try doing some of our exercises in here to see what it feels like. I do have a question, and go ahead, Alex.
I am not finding the screen you have. I'm getting something different.
All right, let me pause the recording here for a second. All right, so the little confusion that we basically had, folks, was if you come up here to the menu, you see like my version just says new notebook, right? But from this screen, and
you're not sharing.
Okay, you didn't even have this screen, did you, Alex, right?
Yeah.
So yeah, I think it might just be a version difference. I'm not really sure, frankly. All right, but hopefully this is at least similar enough for people that they can get it to work. Is anybody else having a weird screen that's different?
What can I ask what version you're running? I think I ended up with 4.25.
Yeah, that's a great question. And I think
Help. Yeah. Wow. So I'm running something else. So I picked up Jupyter Lab. That's something else.
You're running
from...
the Jupyter Lab, which is different than the Jupyter Notebook.
Okay. I'll keep looking.
Yeah, that's actually a good distinction, right? So when you launch Anaconda, and see, I skipped this step, and maybe I shouldn't have, but when Anaconda comes up in your browser, see, I don't like running Anaconda because it does all this stuff that I feel like I don't need. That's just me, right? I like to always conserve resources, and it takes a little while to load. And then when it does load, it's not always super user friendly. But there's a Jupyter Notebook, which is what we want, right? And then there's a Jupyter Lab, right? And not that this isn't a useful tool, but this is the one that we're using. Right, that's the actual like IDE part of it.
Right, thanks.
Right, so I'm going to go back to this screen here, and what I'm going to do now is I'm going to start coding my exercises, and I do have a bunch of these cells here, right, that I kind of have superfluously created. But for right now, I'm just going to use the first one I have, and let's look at our first exercise description because we do have a lot of exercises to do here. So we're going to do exercise 4.1a. And what I'm going to do with this, by the way, is I'm going to grab the instructions and bring them over to the notebook. So I'm going to put in a comment here, and I'm going to say exercise 4.1 A, right? And let's see if that, I did not copy it. All right, now let's try it. No, it's not letting me paste from there. The book does not like me copying. Okay, there we go. So I got to like use their tool to copy, kind of cumbersome. All right, so we're going to write a little program that is basically going to create a loop and do some math, right? to get the sum of all even numbers between 2 and 100 inclusive, meaning we're including 2 and we're including 100, right? So in other words, 2 plus 4 plus 6 plus 8 plus 10, etc., all the way up to 100, all the even numbers. Now, you guys remember from our Kahoot, right? We discovered a way to kind of accomplish that, right, using a for loop. So it's kind of a weird way, like weird first kind of loop to do. But we are going to be calculating a total, right? So maybe the first thing you might want to do is set up a variable to hold the total and set it to 0 to start with, right? I'm just going to do this. In truth, I could make this optional. This doesn't really have to happen here, but from a traditional programming approach, I always like to do this because we do need to store it somewhere. And yes, I'll zoom in a little bit so you guys don't have to squint so much. All right. So now let's build a for loop. So here comes the command for, and I'm going to use the I in range. And then inside the parentheses here, I'm going to put my starting value and my ending value. And also from the Kahoot, we learned that whatever number we start with is actually the number we're starting with, right? So if I want 2 to be included, I'll start with 2. And then I'm going to run a range up to 100. But what we learned also in the Kahoot is that if I want to reach 100, it won't reach 100. I have to go beyond it by 1. So if I want to reach 100, I have to go from range 2 to 101. We can also add a third parameter which controls the increment, like how many we're advancing each time. So if I didn't include this here, the loop would run like this. It would go 2, 3, 4, 5, and it would include odd numbers, right? If I put in the 2, that means it will increment by 2 each time. So it will go 2, 4, 6, 8, 10, etc., all the way through the even numbers. So every time it loops, it will go from 2 to 4, etc. It will add by 2, basically. Now, every time it does that, I'm going to take my total and I'm going to plus equals or add to the total whatever the value of I is. So we started at 0. I'm adding 2 to it. The next time through, it's going to output. What is it going to output? Yeah, that's kind of an interesting thought. Well, you know what? This isn't really necessary here because we want the sum ultimately. So in other words, here's what we're looking for ultimately is this, and I'm just going to drop it in, right? We want it to run the loop and then display what the total is. But it's not unhelpful, by the way, to see what the total is as the loop is running. And then I can turn this off later. Ultimately, I'm looking for the sum, but this is kind of fun to watch. So I'm going to run this and then we'll see it increment as it goes through the loop. And then at the end, it'll show us the total, right? So here we go. So there, notice how fast it did it too, right? All right. And then the question is this correct? Because this kind of begs another question. How do you know that your math in your loops is correct? And what I tell people is often you don't. You could sit there with a calculator, right? So one approach would be I could bring out my calculator and I could go 2 plus 4 plus 6 plus 8 plus 10 plus 12 and go all the way up to 100 and see if it's right. All right. Would take a long time, right? But if you did that, you would find that 2,550 is the correct answer. But it's a little bit easier if you use a spreadsheet, right? So if you're versed that way, and what I'm going to do here is I'll zoom in here, and you'll notice that I'm kind of randomly picking a column here. It doesn't even matter what it is. But Excel's got this power that if I establish a pattern of numbers, like this is even numbers, and I highlight that pattern, then I can take a little bar here and notice how it just automatically keeps incrementing. And I can take this all the way up to 100, right? And then I can just do something really goofy, like I can just take the sum of all of this stuff. And there it is, right? So that's much faster, you have to admit, than putting it in a calculator. But here's my grand point on this. Whenever you're doing calculations and you're not sure what the result should be, you should have some sort of an auxiliary tool to determine what the correct result is so that you know that you're on the right track. Because if I got a different answer and you turned it in confidently thinking it's the right answer, it might not be. Right. So this is kind of just, so every once in a while, if I'm doing complicated calculations, especially if the computer is doing iterations like this or repeats, I don't want to type that all in manually to a calculator. I just don't want to do it. Right. This is a much smarter way to make that happen. And it's accurate. Right. Spreadsheets are built to do work like this. And data analytics person, you will get really good at doing stuff like this. You know, this is what people will pay you money for. Yes, it is a job, right? Okay, so if I strike the total now from here, in fact, I won't strike it. I'll just comment it out, right? I'll run it again, and then it just gives me the output. This is adequate. So this is part 4.1a. But notice how useful that was, right? To do that, because I could see the answer along the way. All right, let's move on to the next one. All right, let's get I think I have a description I can copy from here. All right, so here's my description. Part B is the sum of all squares between 1 and 100 inclusive. All right, so once again, we're running the same range. So the for loop's going to look a lot the same. And we want the sum of all squares. So in other words, we're going to take every number, square it, and then come up with a total. Okay, you know what? Spreadsheet, right? And so I'm going to show you, my approach here. This time we're going from 1 to 100. So I'm going to go 1, 2, 3, 4, 5, etc. That pattern's pretty clear. And then I'm going to take this and drag it down until it reaches 100. Oop, way too far. Sorry, folks. My computer was a little over ambitious there.
Ty, are you doing all the exercises on one file?
That's the whole point of a Jupyter Notebook, Phil.
Okay.
That's a great question, actually, because I can run all the programs in one file, but I have all their output captured at the same time. Right. If you were doing Spider, that would not be the case. All right. Now, what they're asking us to do here with these numbers is they're asking us to square them. So if I was doing it in Excel, I would simply take this number and I would multiply it by this number again. That's a square. And because of the way Excel works, I can just copy that formula down. I'm being careful this time not to over scroll. And it shows all these squares. And then once again, I could do a sum to verify all my stuff. And that's the answer I'm looking for. So this is kind of like the point of this, right? Is I want to know what the correct answer is, basically. All right. So that's kind of the lay of the land in terms of what answer we're looking for. So let's code it. So here, I will now do the same thing I did before. Total equals 0 to start. I have my for loop. I will be in range. And this time we're going from 1 to 100, which means 1 to 101 here. We put in our colon at the end. And then we just, once again, we'll add to the total. And I like to put spaces in there myself. Whatever I is squared. I could just say I times I, or I can do the power thing, I star star 2, which is a square, right? And then we'll just do an output statement. Here's my output statement. I'm going to go to run it. We already know the correct answer. Does that look right? It is. But you see the value of having that spreadsheet output as confirmation is very helpful to know what the correct calculation is. All right, so that's part B. All right. Part C. Now, I created a bunch of these code boxes. So if you want to insert another code box, you just, cell above or cell below. I already had mine, but if you needed to insert some, please do. Here's the description for that one. All powers of 2 from 2 to the 0 power up to 2 to the 20th power. So in other words, I want to know what those values are. That's really what it's saying. It's kind of like a little bit vague. So I'm not keeping a total here. I just want to know what's 2 to the 0 power. What is 2 to the first power? What is 2 to the second power? Right. So you feel where I'm going with that? That's what we're doing here. So I'm going to, once again, create a for loop. And we're going to run in range. And the range needs to be 2 from the 0 to the 20th. So we're really going from 0 to 20. That's our range. 0. Because we're going up to 20, we're going to 21. Then we're just going to do a direct print statement here, and we're going to say 2 space star star double quotes concatenating I is concatenate and then do the math. So the exponent will be automatically generated by the loop. It'll start at 0, go up to 20, and show us what the result is. See, Chris, I see you leaning forward, so I'm making it a little bigger for you. All right, I'm going to hit the run button, and there's your output. Then you should check this, right? 2 to the 0, right? Any number to the 0 power is 1. I don't know if you guys know that. 2 to the first power is 2. 2 to the second power is 4, 8, 16, 32. Yep, those are all correct. And if you go all the way up to the 20th power, it's really interesting how it looks like memory amounts. You start, because it's all binary, right? It's all powers of 2. All right, moving on to part D. All right, got a new box here. I'm going to paste in my instructions. This one says, and I should probably do this. The sum of all odd numbers between A and B, inclusive, where A and B are input. So in other words, we're prompting the user for the numbers. What number are we starting with? What number are we ending with? So you're basically controlling the loop by prompting your user. So you're going to do some really basic prompts here. I'm going to set up 2 variables. One is called A. I'm asking them to input an integer. And guess what? I'm going to ask them to input another, and we'll call that B. Okay, so 2 inputs, both converted to integers. All right, so then I have a couple little caveats I threw in here, and I'm just going to pop them up on screen here in the form of comments so we can talk about them. And I'm going to zoom out 1 click. That's too far, sorry. Still too far. I guess that's the right spot. So if A is even, then the first number we want to include in the total is A plus 1. Right, because think of the prompt here, the sum of all odd numbers between A and B. It's not all the numbers, just the odd ones. So we can't predict if the first one is even or odd, so we have to accommodate for it, right? So we're gonna have to write an if statement. If A is odd, then the first number we want to include in the total is A. Okay, so let's write an if statement that's going to do that. So we have to do a little work before we get to the looping. So first we're going to say if A mod 2. So in other words, if this is equal to 0, so if we divide it by 2 and there's no remainder, that's an even number. If it's even, right, since we want to sum the odd numbers, we're going to set up a variable called num1, and we're going to say A plus 1 to bring it up to the first odd number, right? Because if you know, remember, the point is the sum of all odd numbers between two numbers, the first one isn't odd, so we're adding one to it to make it odd, and then we can do the math. Otherwise, we're just going to do an else num1 excuse me, just equals A, because it's already odd. So if it's already odd, we leave it alone. If it's not odd, we add one to it. Now we're ready to do some more calculations. Then we're going to use a loop, basically, to generate everything else. All right, so once again, we'll set up a total. Here comes the loop. Okay, so what's our starting number then? Well, the starting number is A, but A has been modified depending on whether it's even or odd. So the first number is num1. All right. We're going to run it up to the second number, but whatever that second number is, remember, we have to go one beyond it. So that's the number B, but we're going to say B plus 1 to hit the top end of the range. And since we're only counting odd numbers, we're incrementing by 2. See the logic on this one? Some pretty clever stuff. Then the calculation is very, very simple, right? We're just going to add whatever that number is to the total. Now, this one I can't put in a spreadsheet to predict. I could set up a spreadsheet to verify, but I could not predict it, right? Because I don't know how big the range is that they're going to put in, right? And then ultimately, we have to put it all on the screen. So here's my output message, folks. So there's all the code. So if you're screen capturing, do it quickly. Just say, now I'm going to run it. Here comes the run. So enter an integer. So let's put in some really simple numbers. I'm going to start with 2, and I'm going to go up to 10. So the total of odd numbers, and really should say the sum of odd numbers from 2 to 10 is 24. Is that true? 3 plus 5 is 8. Plus 7 is 15. Plus 9 is 24. It is working. So what if I run it again? Oops, let's go in that box, run that box again. Let's put in the number 3. We start with an odd number, and then we'll go up to, I don't know, 7. So what's the answer going to be? 3 plus 5 is 8, plus 7 is 15. So you see, I'm starting with really simple numbers. The other issue is the range is assumed that the person that's typing in the numbers is typing in the numbers in the correct order. What if? And I'm just going to show you the what if. What if somebody puts in, all right, really big number, and then puts in a small one? It just doesn't loop because it can't. It can't go count up from 1234 to 3. So it just doesn't do the loop. It considers it a false condition and just won't execute it. Interesting, right? Maybe not what you expected. All right, we're going to move on. Doing part E so we can finish up the first exercise. All right, so here's the instructions for the first part of E. And it says the sum of all digits. All right, so I'm going to add another line here so we can see it. Of an input. For example, if the input is 32677, the sum would be 3 plus 7 plus 7. Only the odd numbers in the number are getting totaled. This is kind of, once again, an interesting little example, where I think of other languages and how I would do this, and it gets really complicated, and Python makes it so darn easy. All right, so first thing I'm going to do is I'm going to capture the number, but I'm not going to capture it as a number. I'm not going to convert it. I'm going to leave it as a string, because if it's a string, I can traverse the characters, right? So I'm just going to create a variable called digits, and then I'm just going to say very simply, enter an integer. Little do they know it will stay a string, but that's not for them to decide. Right. And then here's my little instruction set here. Check each character in the string, begin by converting it to an integer. If it's an odd digit, then add it to the total. Okay. Well, you know what? We need a total to add it to. So let's just set up a total. There it is. Then we are going to run our loop. So this is where it gets kind of interesting. When we work with numbers, and we normally do a range, right? So we say, start with this number, end with that number, right? And we have an increment amount or maybe a decrement amount. But now we're working with characters. And so the convention when we're working with characters, and this isn't a rule, by the way, it's a convention, is to say that for each character in whatever string we're looking at, so that in this case, the string called digits, meaning I will automatically take whatever they type in and traverse every character of it. That's what this statement does. Think about how powerful that is, especially if you guys have learned another language, like you're learning Java right now, or you've done C# or whatever, and you look at this statement and what it's accomplishing with like zero syntax almost. It is highly impressive, right? Super powerful, super simple syntax. All right, so the maneuver then that we're going to take is that for each character in there, I'm going to set up a variable that's going to receive the conversion of that character into an integer and store it in a variable called n. Then I can check it mathematically, and I can say if n, once again, we're looking for odds and evens here, right? Or we're looking for odds. Well, we know how to figure out if something is even if we basically mod by 2 and it's 0, then it's even. But if we mod by 2 and the remainder is 1, then it's odd. Right? It's an odd number. Clever, right? Yeah, I didn't come up with it, but I think it's clever. So if that's the case, if it is odd, then I will add it to the total. Another thing that you might want to do, and once again, this isn't obligatory, but often when I'm doing stuff like this, I sometimes add stuff in the loop to see how it's working along the way. So I'm doing this. I'm saying that I'm indicating which number is being added and the current total as we're moving through. And once again, this is optional. You don't have to do this, but I am doing it because I think it helps me when I'm programming to see that the steps are working correctly. And then finally, I'll do the complete output. All right, I'm going to go ahead and run this, folks. Here comes the run. Okay, so I'm entering a long integer. So I'm just going to do something really simple to start with. I'm going to go 1, 2, 3, 4. Okay. What should the answer be here? Is a total. I'm adding just the odd numbers together. 4, right? Thank you, Alex. Right. But notice what I did here is the number being added, 1. The current sum is 1. Number being added, 3. The current sum is 4. All All right, so let's try a little bit bigger number just to show you that it won't choke on it. And this is the part that I think is really fascinating. Right, I'm just running my finger on the numbers on the top row of my keyboard. Right. Oh, wait, that's not the right spot. But you know what? All right, let's come back up here. We got to activate that cell and hit run. And I'm just going to paste that number in. I don't know what the correct answer is. I can figure it out. But there it is. It shows you what it's doing as it's doing it. And notice how large that number was. I mean, the processing is like lightning fast. So it's taking it as a string, converting odd numbers to odd, doing math with it only if appropriate, and giving us the result. I like throwing print statements in my loops, at least for testing, just so I can see what it's doing. It is optional, though. This is not required. But I do find it helpful because it shows you what the loop is mechanically doing as we're doing it. Moving on to exercise 4.2. And you notice this one says, write programs that read a sequence of integer inputs and print smallest and largest of the inputs, the number of even and odds, the cumulative totals. For example, if the input's 1, 7, 2, 9, the program should print 1, 8, 10, 19. All adjacent duplicates. For example, if the input is 1, 3, 3, 4, 5, 5, 6, 6, 6, 2, the program should print 3, 5, 6. In other words, it'll only output the repeating numbers. Now, if you're picking up on the challenge here, part of the challenge is that you're prompting your user to enter information, right? And how much of that information are we going to capture until we stop? Okay, this is kind of an interesting little dilemma. So it kind of gives us I'll put it like this. The assumption is, like we did before, that we're going to type a sequence of characters all in one line and then press enter. That's not how this is going to work. This is going to be single characters, each typed individually with a key press of enter after each one. How do I know when to stop capturing those values? This is kind of the conundrum. And basically we're going to switch loop structures here. And this is where the basically a while loop comes in really handy. And so I want you guys to follow along with what I'm doing here, because this is a little bit different than what we did before. Okay, so I'm going to do, let's say, the first part here. So this is going to be in multiple parts. We're going to work on the smallest and largest thing first. Okay, so that's kind of our goal here. All right, so let's jump over to the Jupyter Notebook. I'm going to call this exercise 4.2a. The goal of this one is, what was the goal of this one? Smallest and largest? Smallest and largest of the inputs. All right, so I got it captured over here. So I'm just going to put it right there. All right, so let's jump past the comment mark here to code this. All right, so first thing we're going to do is we're going to grab the first value from the user. That's our first step. Okay, here's my prompt. And just say enter an integer or a blank line to quit, right? And I don't want to really go down the rabbit hole here too far, but let's just kind of skip past some of the logic for the moment. And I'm going to engineer the while loop first, and then I'll fill in all the other parts. And I'm going to show you what this means, basically. So whatever they're typing in is what I'm going to call the input string, right? Because it's going to come in as a string. And while that input string does not equal a blank, then I'm going to do whatever code I need to do. So like, for example, and I'm just going to do this here as a comment, do whatever you need to do. And then while I'm still in the loop, I'm going to prompt the user to do the input again, right? So we do whatever maneuvers we do, and then we ask the same question again. So we'll type the number, we do our code, we ask them again. If they type a blank, then we quit. All right. And then just to prove that it's working. Okay. So I'm going to run this. This is really kind of weird, right? Because it's not going to do anything except for take numbers from me. And then when I type nothing, quit. I just want to show you the concept, right? So here's the run. This is the example, right? So I'm going to enter a 1, a 2, a 3, a 4, nothing, and then it stops. Right? See the logic there? So the problem with a while loop, and it's not a problem, right? It's the feature of a while loop, if you think of it like that, is if I need to test a condition to run it, I better make sure I capture the condition before the loop gets there. Right. And so remember, we talked about the sentinel value or the loop control variable. The sentinel value that we're looking for is nothing. So I'm looking for them to type nothing or just press enter. As soon as they just press enter, the loop is done. As long as they're typing something else, the loop will keep going. All right. So that's kind of the basic lay of the land. Now let's get the logic in there. All right. So if Well, think about this, right? So the first thing that they type was an integer. We'll process it, and the remaining input values, otherwise an appropriate error message is displayed. So, for example, what if they don't type anything to begin with? Okay, well, that's kind of a problem, but we still need to kind of capture it. So if they type nothing, so I'm going to type an if statement that says if input string does not equal blank, then what I'm going to do is I'm going to capture that value. I'm going to store it in a thing called value. And I'm going to take the string that they typed and convert it into an integer. So I'm turning it into a number for step one, right? Because it was a string. And then since we haven't declared any yet, it's also the smallest number. It's the smallest number and it's the largest number. That's our baseline to start with. Okay. Now some more logic. So here's my logic. And I do this so that you have like the thought process that goes with it. So as long as the user hasn't entered a blank line, convert the input to an integer and determine if it is the new smallest number or largest value. And then we go into the loop and do it again, right? So we'll do that in the loop. So some of these steps are basically going to repeat, but now we will convert the number every time. So, all right. So the conversion will happen at the beginning of the loop. And then we need to check, is the value that we're currently working with the smallest one or the largest? So I would say something like this. If the value is smaller than the smallest number, then the new smallest number is the value. And conversely, if that value is bigger than the largest number, then that's the new largest number. Then we prompt again. So that's our logic, by the way. All right. Then we need to show the results. However, and here's the however, I want you to think about this. All of this is happening only if this is true. So I'm actually going to indent this one level. So you see how I did that? I highlighted all the code and then I pressed my tab key and it moved it all over together. right? So what I'm saying is it does this step, then it runs the while loop. We're still inside the if statement, right? We know the while loop will run if the if statement is true. If they entered a blank, we don't want that to execute, right? So what we'll do is down here where I have a print, instead I will have an else. And then basically we're just going to put an error message on the screen. So if like they start the program and they don't type anything, and then we'll just have a little message that says no input values were provided. And then, you know what? Ultimately, we're going to need to display when it's correct, right? So when is that going to happen? How about when the while loop ends? And that will also be inside the top part of the if. Right, so here it comes. So I'm going to put it right there. And I know that's a little weird. Let me just zoom out like that. Right, so that's where I'm putting it. Trying to get it all on the screen at the same time. So here's my if, the while loop inside the if, the output. You see, I'm kind of breaking it apart so it's easier to see. And then the else. And then you know what? Why don't we put a little thing at the bottom? And this is kind of a goofy little nerdy thing that I often do. Is sometimes when I'm not sure that the program is over, I just put in a little message at the end saying program complete. And I have the voice of the Star Trek computer in my head that's saying that, you know, like some like program complete. If you guys are Star Trek fans, you know what I'm talking about. All right, let's try running this. And I know you guys are probably still copying code. Just remember the videos are coming out tomorrow. So I'm going to hit the run button. It's going to enter integer. I'm just going to type a blank line to quit right away. No input values are provided. Program complete. Let's try it again. Got to come up here, make sure the box is active and hit run. All right, so I'm going to type a number. Is the smallest value 0 and the largest value whatever that was? Yes. Once again, just for the sake of making this easy, there you go, screen capture people. You got 5, 4, 3, 2, 1. See how fast you can screen capture? No, I'm just teasing. I know, that's kind of mean, right? I know you guys are doing that, so no harm done, right? The next exercise was the number of even and odd inputs. Okay, so we're going to follow very much the same pattern on this, by the way. So all I'm going to label this, by the way, is 4.2b, and I'll zoom in a little bit again, make it a little easier to see. All right, so we're going to borrow the same prompt and copy it from above if you wish. We're going to set up one variable. We'll call it even. We're counting the number of evens. We'll preset it to 0. Counting the number of odds. We'll preset that to 0. And then we'll just very simply say, while the input string does not equal a blank, then we will convert. So you could copy this from above too, same statement. Convert it to a number. And then we're checking to see if it's even or odd. We kind of already know this, right? So if the value mod 2 is equivalent to 0. That means it's even. So we're going to add 1 to the even counter. Otherwise, it must be odd. So we're going to add 1 to the odd counter. Then we will repeat our input statement to prompt again. And notice where the indents are, right? So basically all of this stuff is inside the loop, folks. Right? So we're prompting inside the loop. All they have to do is type a blank line to quit. And then as the program exits, right, the final line is going to be this output. The user entered so many even values and so many odd values. All right, let's try this. This is a pretty simple one. See if I can get it on the screen and get the output at the same time. So I'm just going to do a really basic one. I'm just going to count up through the numbers of the keyboard here. We go 1, 2, 3, 4, 5, 6, 7, 8, 9. That's pretty good. Now we'll do a blank line. 4 even values and 5 odd values. Is that true? It sure is. You guys are scrambling to copy, so I'm trying to be polite and let you. All right. Meanwhile, the next directive is the cumulative totals. For example, if the input is 1, 7, 2, 9, the program should print 1, 18, 10, and 19. Now, this one takes a little bit of thinking in terms of where you're putting your loop and where you're putting your output. So we'll just call this, let's see, exercise 4.2c. We'll call it cumulative totals if you want to title it. Same approach. We'll use the same prompt again. We'll preset a total to 0. We'll do the same basic first steps of the while loop. So as long as it's not blank, we're converting it to an integer. And then we're going to add the value to the total, except do it on the next line, folks. There we go. And then instead of outputting the total at the end, we're going to output it, put it inside the loop so we can see what it is as we go. And then we'll prompt again inside the loop. And then you can be a geek like me and say, and I know this is really silly, but I do like putting this in because then I know the loop finished. You see my thinking? As goofy as that is. Like, thank you, come again. You know, kind of like that. All right, I'm going to do a sample run on this. So far, the total is good. I assume it's right. Hopefully that's right. I'm not going to put it in the calculator, but you could test it, right? So this is kind of like an accumulator, right? So it's just accumulating value, and we're seeing the result each time. The print statement that shows the total is inside the loop, so we see it as it goes. And then a blank line to quit, and we're program complete. But can you see why that's actually helpful? Like, you know, it's done. And maybe I could be snarky and say, thank you, come again. All right, let's move on to the next part. Reading the next instruction. All adjacent duplicates. For example, if the input is yada, yada, yada. So whenever two numbers are typed in a row, those are the ones we want to show as output, right? Whether it's repeated twice or 3 times. So this is going to take a little more sophisticated thinking, but not as much as you might think, right? So first thing we'll do is we will prompt. So here comes the prompt. Same one, copy paste. Now, in order for us to know if a number's been repeated, I'm always going to have to look at the one that was just typed to see if it was repeated or not, right? So I'm just going to set up a variable and call it prev for previous, because I don't want to type the whole word. And I'm going to store the current number in that variable when I capture it, right? The other thing I'm going to do is, well, it only wants me to output the ones that were printed already. So in other words, if I type 1 and don't type it again, and then I type 5 and 5, well, I want to output the 5. And then I need some sort of a way to know, did I already type this number out? Because what if I type 5 3 times in a row or 5 times in a row? I don't need to put that up on the screen more times. Once is enough. So I'm going to create a Boolean value called printed. So this is a true false. And I'm going to preset it to false. Right. And you'll see how I use this as I move forward. All right. Let's do the same while loop check. We're going to say while the input string does not equal a blank. Right. Now this is kind of weird because what processing can we do at this point? There's no processing we can do. We have to have at least 2 numbers before we can process. So I'm going to do another prompt right away. So I'm going to just put in, the first thing we're going to do in the loop is prompt again. Give me another number. Thanks. Right. But keep in mind, the one I typed up here is stored here. All right. So now I can compare them. So now I can say, if the previous number is equivalent to the current one I put in, spelled correctly, right? And printed is equivalent to false, means I haven't printed it yet. I can type it. Then I'm going to put on the screen the thing I typed, concatenated to is a duplicate, right? But since I don't want it to print again, then I'm going to take the printed Boolean value and switch it to true, indicating it has been printed. So don't print it again, right? Because in order for it to print that it's a duplicate, it's got to be false. So this condition won't check even if this is true, because both things in an and statement have to be true for it to execute. Right. Right. So that's the one condition. But if the previous one does not equal the input string, then what do we do? Well, we'll switch it printed back to false. So if we found another duplicate, then we can put it on the screen. Then whatever they entered before will be stored in previous. So the one that they're capturing here is going to previous now for further checking. Right, so that'll be the previous that we check here the next time around. Is there anything else I need for this program to run? No, but here's me being goofy again. I'm going to say print program complete. Or thank you. Come again. This is me trying to have a little fun. Not many laughs on this one, right? Here we go, folks. I'm going to run it. All right, enter an integer or a blank line to quit. So I'm just going to type 12. Well, no, let's do single digits. 1, 2, 3, 3. 3 is a duplicate. 4, 4, 4. So it's notice it doesn't print as a duplicate again because it already happened. 5, 6, 7, 7, 8, 9, 9, blank, and we're done. So that's how that one works. That was part D, and I think that's all of 4.2. All right, let's move on to 4.3. That one is also a multi-parter. You guys are dreading this now, right? There's only 5 exercises. Yay. Too bad every exercise is 5 exercises. Right, but we're really kind of learning some nuances with loops this way. Otherwise, we might not pick them up. That's really kind of the grand point here. All right, I'm going to move on to exercise 4.3. Write programs that read a line of input as a string and then print only the uppercase letters in the string, every second letter of the string with all the vowels, yada, 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 yada. Okay, so we're going to do all those tasks. Okay, so I'm going to do this kind of a little bit different way. I think I might do a little combo here. So I'm in a new thing. So I'm going to call this exercise 4.3. And we'll start with the input again. This time we're not doing any conversions or anything like that. So I'm just getting an input string. I'm going to say enter a string. It's basically equivalent to type something. All right, so now I'm going to do 4.3a. 4.3a was only uppercase letters. If you want to type that in, you can add it here. Only the uppercase letters. So this one I'm going to do with a for loop. So I'm going to say for each character in the input string, so it'll automatically traverse the structure. If the character, and this is where we use some of the built-in string functions, right? So this is a function that's built into the string class that can automatically check to see if the letter is uppercase or lowercase. It will return true or false. So it works with an if statement. So if the character is uppercase, we are going to print the character back to the screen. However, we are going to, because there's going to be more than one thing potentially typed in the string, right? It's going to type more than one character. I'm going to put in this weird command. I don't think that we've used this yet, but it will keep the cursor on the same line and then output the next thing after it, right? All right, so I'll show you how that works in just a second. But we also have to contend with this other aspect of it, which is what if it's lowercase? Okay, so all right, so this is only going to indicate which letters are uppercase. That's what it's going to print out on the screen. But what if somebody types in all lowercase letters? Okay, I'd like some code to kind of compensate for that. This is not inside the loop. So what I'm going to do is I'm going to take that input string and I'm going to run the isLower function. So basically, if the whole string is lowercase, this will detect it, right? Then I'm just going to do a simple little message that says no uppercase letters in this string. Just like that. All right, so let's go ahead and run this. So there it is, enter a string. So let's do all lowercase. Let's try that first. Notice semicolons in there. They are not uppercase. They're not even a letter technically, but they are a character. run it again. Let's just do something. Okay, run it again there. All right, let's do whatever with a capital W. And there's my capital W, right? If I did something like putting, I don't know, John Smith. I don't know, I'm stretching for names here. It's just giving me the capital letters. Now, if you don't want those letters touching each other, by the way, you can add a space here and run it again. Kind of slick, right? Okay, maybe you don't feel that it's slick, but this is doing some pretty, once again, sophisticated language processing with very little code. And we have some other parts here we have to do. So let's try to hit these really quick. Every second letter of the string. Now, normally I would start a new little program block, but I'm going to actually put it right here in the same program. So I'm just going to do a blank print statement to move us down a line. And then let's go to 4.3b. Here's my thinking on this. They already typed in a string. So why ask them for another string? Right. All right. And so maybe we would want to do something like this. And I'm just kind of thinking out loud here. Print. And actually, I'm not going to put it there. Or should I? All right. I'm thinking this backwards. I'm going to actually put this up here. And before I go into this loop here, I'm going to do an else. And I'm going to say, if there are uppercase letters, then I'm going to do this. The uppercase letters are, and then I'm going to use the same concatenation approach here where I'm going to do the end thing with spaces in between. Like that. Can I test this so far? Let's do that. All right. So Homer Simpson. Okay, that works. See my logic, right? Hopefully. All right. Let's get rid of these blank lines. Let's move on to 4.3b. Now we're going to display every second letter. I'm not having them re-input anything. Now we're just checking. So how would I have them display every second letter? This is kind of a logic thing. All right. If the length of the string is even, how long do I check? Okay, so what if the length of the string is 0? That might cause an error state, right? I can't really analyze that. So I actually have to put in an if statement to accommodate for it. So I'm going to say, if the length of the input string is greater than 1, then I can loop through the contents, but not before, right? And so in that scenario, I'll say if I is in range of 0, okay, to what? Well, it's greater than 1. So I need to go from the 0 position in the string to the last position, but the last position's index value is 1 less than the length, right? But in the range command, I want to go 1 beyond. So I just use the length. This is really kind of a weird thought. In other languages, we would be subtracting 1 here, right? So Java, C# people, right? And then we want to go every other letter. So we're incrementing by 2. And then for every time we do that, we're just simply going to print out the input string, current position. What position are we in currently? And then we're going to concatenate that on the same line again. So it all stays on the same line. And I'm putting a space in between. Okay, we need an else in here. Because what if the length is not greater than 1. What if the length is 0? So I need an else. And then I'm going to have just a simple message like this saying the item is too short to display any characters. All right, so that would be that part. And then I'll put another blank line in there and we're done. So let's run it now. So it's going to do and I'll test both scenarios, right? So is it showing every other letter? Yeah, it is, right? It's kind of like it's like erasing them from the string. All right, let's try it again, but run it with nothing. Still correct, right? There's no, the uppercase letters are, well, there aren't any. The item is too short to display any characters. That might, you could engineer this differently. All right. Next one is the string with all the vowels replaced by an underscore. Okay, that's kind of a weird one. All right, but let's add that to the same program here. So this will be 4.3c. And what was the directive? Vowels replaced by an underscore. All right, so how would we do that? And kind of a little thing I typed in last time was this. We have it available. Doing this with a for loop again, I'm just going to do the for character for every character in the input string. If the character is in, and this is really kind of a cool thing too. So watch how this is done. A, E, I, O, U, or A, E, I, O, U. So I'm creating a new string with all the vowels, lowercase and uppercase. So yeah, I could convert the input string. I could make it all lower or all upper and whatever. But here I'm just checking to see. This is kind of a brute force thing. Every character, I'll step through every character in the string, look at each one separately, and if that character is included in this string, then I will output an underscore. So I'm going to print underscore. We'll concatenate that to that end thing again, but this time we don't want a space in there because we want it to maintain the structure of the word, right? And then it'll put it back on the screen with vowels replaced by underscores. All right. What if it's not a vowel? Well, then we'll have an else, and then it will just print the character itself and append it to the end with no spaces. Let's run this one. Okay, so what are we doing here? We'll stick with Homer Simpson. Interesting processing, though, you have to admit. This is a strange little exercise this way. An interesting output for sure. All right. Next one that we're doing is the number of digits in the string. So I'm just going to copy this in. I'm trying to accelerate our workflow here because we are running out of time really, really fast if you guys aren't noticing. All right. All right. So we'll do the count because we're going to count these things. So we're setting a counter at 0. Once again, we're going to say for each character in the input string, we're going to loop through. If the character is greater than or equal to 0, this is kind of weird. Why the heck would I say this? Here. Okay, this is kind of a thought you might want to mull over a little bit. And the character is less than or equal to the number 9. Well, because they're asking for the digit. So if you type a number in the string, they want to count it. That's what they're doing, right? So then we'll do a count plus equals 1. If it's just letters, it won't matter. See the point? And then once it loops through, then we want a print statement. And let's get some blank ones in there. All right, let's run it. Oh, okay. So what did it say here? Line 36. Oh, no colon. All right, run it again. All right. So this time I'm going to type Homer Simpson 2. Yeah, and you know what? I never did a print statement here, so that's why I put those in, just to clean that up. That's part D. All right, we got one more part to do, you guys. We're getting there. This one's kind of weird too. The positions of all the vowels in the string. All right, so I'm going to start by saying this. So we're staying on the same line with the output. Now I'm going to run a for loop that says for I in range, and we're starting at position 0 because the first index value of a string is 0. Then we're going to the length of the input string, right, which is 1 more than the highest index value, just to kind of reiterate those concepts. And then we're going to check and see if the input string current position that we're looking at, so subletter I, is in, once again, here's our vowels, A, E, I, O, U, A, E, I, O, U. We're going to print the current character, and we're going to do it with spaces like that. Here comes the final run. All right, so this tells you all the vowel positions. Isn't that kind of a strange one? And I tried to make sure that I got numbers in there. Yeah, 1 uppercase letters, vowels being replaced, but it really kind of shows you the elegant like processing capability of Python working with language with minimal code. When you combine it with a data structure like a string that has index values for the position, we can traverse it really, really easily. Very, very powerful stuff. And you might not be feeling that quite yet, but you'll see it as you kind of move forward. All right, next exercise is exercise 15. I'm looking at the clock. We'll see if we can try to pump this one out before we go. I guess I'm working in the Jupyter Notebook because I don't want to switch products right now. So this is going to be exercise for 15. Yeah, 15. Our directive here is what? Let's read. Ah, the Fibonacci sequence. Normally I do a whole little dog and pony show on this, by the way. But this is kind of an interesting thing because it's actually a strange algorithm. And rather than get into the complete specifics about it, I'm going to kind of Google it a little bit. And what I typically do is I just go to the Wikipedia page on it, right? Because they have some kind of an interesting little thing. But the Fibonacci sequence is basically a sequence where you take, excluding I think the first two numbers in the sequence, each number that follows is a sum of the two numbers preceding it. This is really kind of a weird thing. When you take the numbers in the sequence, so in other words, if I take 0 and 1 and add them together, I get 1. If I add 1 and 1 together, I get 2. If I add 2 and 1 together, I get 3, right? Now, this is like, we can look at this. This is like rock, paper, scissors again. I can explain it to you very quickly just by doing that, right? Totally get it. But if you look at the mathematical proofs on it and what the formulas look like, they're insanely complicated calculus equations that you would like, I want to give up on math. I never do math ever again in my life, right? That's kind of like the feeling you get from it. And please don't feel that way, because remember, mathematics with its weird notation is sometimes just trying to explain very simple things that we understand quickly, but to do it mathematically is a different thing. But what's fascinating about this sequence is when you plot it out like this graphically, notice like 1 and 1 equals 2, 1 and 2 equals 3, 3 and 2 equals 5, 5 and 3 equals 8. And you see what it does here is it naturally forms a spiral. And you notice that if you map the spiral, it creates a naturally occurring spiral. Once again, another one of these things that you see in nature all the time that happens with like living and growing beings. It's based upon very simple algorithms. I think it's just astounding when you think of it that way. All right. The trick, though, is to take this description that they have here, which if I were to, once again, leave you on your own to figure this out, you would probably never get it, right? Or some of you might, right? If you're a mathlete, but let's face it, most people are not mathletes, right? So I'm just going to code through this really quick and convert this into a Python program to show you how it works, right? So what we're going to do is we are going to prompt the user for a value, right? So we want them to put in, an integer, and then we'll count out the integer starting at that point, right? So that's that. The next thing that we'll do is we kind of have some special situations with the Fibonacci sequence, right? Which is the first two numbers, right? So if the first number is 1, we're going to store it as a new number, right? So that's what that is. Fibonacci new is what it stands for. If we have the number 2, then we'll also store that as a new number and set Fibonacci new to 1. Otherwise, we will go into the actual sequence, which looks like this. And I'm dumping it all on the screen at once because I'm looking at the time. All right, so I just want you guys to mind that. Normally I would do a lot more talking about it. Otherwise, then we go into the little fold thing that they're talking about. So we set up fold 1, fold 2. We run a loop that adds the fold 1 and the fold 2 together into the new. Fold 1 becomes fold 2, and the new one goes into 2. And really what I'm trying to do here with code is the same thing I was doing before on the screen, where I took 1 and 1 and made 2, and 2 and 1 made 3, and 3 and 2 made 5. I was just doing the same thing, but this is how you say it in code. The problem is if you're in the first two positions, right, that sequence doesn't work because you don't have enough numbers to do it with yet. That's kind of the thing. So the ultimate output here is this. this will tell us where it sits in the sequence. So I'm going to run it really quick. I know this is kind of a weird one, but it is what it is. So I'm going to type in a small number, 5, right? And it shows you all the numbers in the sequence, and it shows you the 5th number in the sequence is the number 8, right? So the point of this, right, is if I wanted to put in a much larger number, let's say like 44, and it shows you all the numbers in the sequence, and this is where it gets really bizarre, right? Look how big those numbers get after 44, right? And if I run it again and put in a much larger number, notice it took a second, right? It hiccuped for a second, but holy cow, folks. This is, what number did I type in? I didn't type in a very large number. I typed in, okay, well, 123,456. This is the Fibonacci sequence. And it just, and this is, mind you, in my browser. With some of the last numbers in the sequence, I don't know if you guys are catching this, are just humongous. Oh, I exceeded the data, right? So I didn't push it very far, and it was able to do this. This is pretty intense stuff, right? Yeah, so it is possible. Oh, it kept going. It's still doing it. What a trip, right? I don't know if I can stop the execution at this point. You know, if I was at a command prompt, I would sure know how. Yeah.
Maybe the stop button at the top.
Yeah, probably. All right. I think we're good. But you know what it did here? Yeah, so we interrupted it, but it kept trying to go. But think about this. If it generates a number that's like 5,000 characters long, and it adds it to the previous number, which is 4,000 characters long, can you imagine how big these numbers get? I mean, it's just insane, right? And it's got the capability to do it. And I'm really only limited by the settings I made in my computer. All right. I'm looking at the time. And what I will say is, for those of you that need to go, feel free to go. But I'm going to keep recording the last exercise. And if you want to hang out for it, you're welcome to. If you want to go, it's up to you. You just watch it in the video tomorrow. The solution also is pre-recorded in my previous bank of videos. So you just watch part 2 here, and that solution is there. But I will add this video to that. Well, this video will appear here tomorrow. All right. For those of you that have to go, I totally understand, but I'm going to keep coding. All right. One exercise left.
Have a good night.
Have a good night, you guys. Exercise 18. All right. So this one says, write a program that prints a multiplication table like this. But notice a couple things happen here that's kind of interesting. Like, I think I could probably work it out where I could print out the number 1, 2, 3, whatever. But you notice, like, when I get to 2-digit numbers, it leaves enough space here so that these all line up. So all the singles digits are together. And then when I get to 100, it also allows room for that 100. Right. And by the way, the ... means all the rows that we're not seeing. So it'd be 10 across and 10 down that we would be doing here. All right. The thing that I think is really astounding about this program is you can do it basically with 3 lines of code in Python. This is, you know, kind of mind-blowing, really. So I'm just going to kind of type this in here. Let me get my exercise 4.18, and we'll just call it multiplication table. I'm going to do this with a for loop. I'm going to come up with 2 variables, an X and a Y. I'm going to set up 2 loops here. So there's going to be 1 loop inside of another loop. Because think about this, when you're doing a multiplication table, I have 1 loop that will make you do 1 row. And then there's another loop that will take me down to the next row and do the next loop. So this happens in the inside loop, this column, the 1 through 10 here, going up and down, happens in the outer loop. So I'm going to call that one Y and this one X. That's going to be my pattern. So I'm going to say for Y in range, and I'm just going from 1 to 10. So I can go 1, comma 11. I want to get up to 10. So I have to go one above. And then I'm going to have the same thing on the inner loop, but I'm going to call it X and say for X in range, 1, comma 11. And now it's just a matter of formatting, right? So I'm going to print. This is how I figured it out last time. So, follow along if you wish. I did a % for D, which means I'm leaving 4 space digits for each number that's printing out, because the number 100 has 3 and I need space in front of it, right? So that's how I'm going to do that. And then I'm going to use my wildcard, which will feed information into this spot. What am I feeding in? The result of the calculation of X times Y, right? So that's going to kind of automatically generate, because the outer loop's going to start at 1, and then the inner loop is going to count 1 through 10. Each time it counts through 1 through 10, it's going to multiply against the outer loop's value, which starts at 1. So the first time I get 1 through 10, the second time Y will be 2, and I'll get all the multiples of 2, etc. And then since I want the stuff to print on the same line, I'm going to use the end thing. I'm controlling the spacing here, right? Because that will format my numbers nicely. And that's it. That's all the code, believe it or not. And I think so highly impressive to have such a small amount of code. And boy, that didn't look good. What did I do wrong? Is it my zoom level? All right. You know what's happened to me? Am I locked up for you guys? And I think what's happening is this,
No.
this iteration here above is still messing me up. Yeah, it says my changes won't be saved. Okay, I'll refresh. And I think really I put in way too large a number there. All right, so here's what I'm going to do. I have a pre-existing version here just to show you that it actually does work. Right, so this is my iteration from spring, and actually earlier than that, but I'm just going to run this one here just to show you that it does work correctly. It just, I was locked up with that other process, so I apologize for that. And I don't think I typed anything in wrong there. Nope. Ah, okay. So here was the problem. I forgot to put the print command in to move me down a line. So I kept going across. That was the problem. Okay. 4 lines of code. But still, I think very impressive for just 4 lines of code. It's just not a lot of code to create the output. But I'm glad I had this version. I'm curious if I go back to that other window. Okay, that's the same window. Yeah. All right. Yeah, this one's still locked up because of that value in there. Okay. So I'm just going to close that tab. Okay. That was not a great choice. So I'm going to have to go in there and manually edit the value to not have it crash next time I look at it. But that was the solution, folks. All right. So we are all done. This video will end here.